All right, good morning. So we're going to go through and we're actually going to start our next unit. With me being at sixth grade camp this week, it's going to be easier for us to move on to our next unit. The moon phases unit we'll finish when I come back from camp. So I know we were talking about having a test on Wednesday. We're going to postpone that until the week after, so next week. And we have enough stuff here to get us started. And this is a type of unit I think you guys can go through on your own to learn about the atom, elements, periodic table. So this will be the first of videos, and I'll probably have a video either each day or I'll tell you where to stop the video and where to come back on the next day, just kind of depending on how much you get done at work. As always, and this is important, I'm expecting you to get this work done. Okay, we still are going to have two small assessments, quizzes, whatever you want to call them. One on moon phases, eclipses, and tides, and then on this information with the atom and the periodic table. So it's important that you get this stuff done and that you're doing it in a way that you're learning about it, because you're going to be responsible for knowing the information. So let's take a look at how we're going to get started today. The first thing you're going to do is you're going to log into Study Island and you're going to take the pre-assessment. And again, we like to take pre-assessments so that you can see a little bit about how much you already know in terms of background knowledge, and that helps me as well. But also it gives you kind of a roadmap of some of the important concepts and the objectives that we're going to try to accomplish during this unit. So that's part one. Part one today is for you to go through and to take the pre-assessment in Study Island. It's already in there. Once you have done that, come back to the video. All right, so now that you've taken the pre-assessment on Study Island, the next thing you're going to do is on Google Classroom, you'll see that there are two Google Slide presentations. One is my presentation that is completely filled out with all of the notes. Your job is to fill out the student version by using mine to kind of type in the missing words or the missing phrases as you go through. So when you open up those two docs, you can kind of like split them and put them on your split screen so that you can see them as you go. I'm actually going to talk though through the notes. And so it's not just you going through and just copying and pasting slides or something like that. I want you to actually listen as I go through and explain some of the information on the notes, just like we would be doing in regular class. So make sure that you're doing this. If you need to pause at any time as you're typing, because I'm not really going to pause for you guys to type like I would in normal class note situation. I'm just going to kind of keep going. So if you need to pause, make sure you pause. You'll see to start, there's going to be a video that's at the beginning for you to start to watch on an introduction to atoms and elements. So watch that video and then come back to this, to my video here, to this recording, and we'll go through and we'll start taking notes and talking about the atom. Okay, so let's go through atoms and the periodic table now that you have watched the video. So like he said in the video, atoms are the smallest component of an element having the chemical characteristics of that element. And every single piece of matter is made of an atom. We're going to go through parts of the atom here in a little bit, but everything that has matter, whether it's solid, liquid, even gases, sometimes we forget about that, but even gases are made of atoms. Inside your body, the smallest unit of structure and function are cells. Even cells are made up of atoms. They are the basic building blocks of all matter. Now, sometimes what gets confusing is the difference between an atom and an element. Well, an atom is kind of like the generic term for all the smallest things that make up all the matter. But an element is a specific type of atom. So an element is a fundamental material consisting of only one type of atom. And so we can talk about differences of atoms based off of which element they are. And there are characteristics of a hydrogen atom that are way different than the characteristics of, let's say, a uranium atom. Both can be a single atom, and they both are made of the same components, but they have some differences, which makes that atom slightly different from another. And that's those specific atoms are the elements then. So if you have one atom of a specific type of material, then you're talking about an element, or we can just talk about atoms kind of generally. 90% of elements occur naturally on the Earth. So they just, in our planet and even in the universe, there are just these elements that were there when the Earth and the universe were created. And these naturally occurring elements literally make up everything that we have. And so think about the alphabet. The alphabet has 26 letters. And think about all of the different arrangements of those letters that you can have. All those different arrangements give us millions upon millions of words in the English language. And that's just with 26 letters. So now think about 90 naturally occurring elements and all of the different variations that you can have of those 90 to make up everything. And it's not just, a hydrogen and an oxygen atom. Well, it could be if you have 2 hydrogen atoms and 1 oxygen atom, then you have water, H2O. Or you can have 2 hydrogen atoms and 2 oxygen atoms. It's still hydrogen and oxygen, but now you have 2 of each, and now you have something completely different, H2O2, which is hydrogen peroxide, something completely different from water that you would not want to drink. And so it's with all of these different elements and all the different combinations of how they combine to make up everything that we have on our planet. So what makes up an atom? Well, there are 3 things that we need to know about the parts that make up an atom. And we call these things subatomic particles because they're smaller than an atom. They're not technically considered pieces of matter, whole pieces of matter, because the whole piece of matter is an atom. So protons. Protons are positively charged particles in the atom. And there you can see the mass. They're tiny, 1.673 times 10 to the negative 27th kilogram. So that means we take and move that decimal 27 places to the left. So that means there's 26 zeros before that 1673 kilograms. That's how small they are. A neutron is relatively the same size of a proton, but it's neutral. Neutral neutrons, positive protons. Sometimes kids get confused and they think, positive protons, negative neutrons because of the N. But it's not negative neutrons, it's neutral neutrons. And then our electrons. Electrons are negatively charged. Negatively charged electrons are in the atom, and they are even smaller than protons and neutrons. And it doesn't seem like it's that much smaller, but it really, really is. Electrons are tiny. Okay, so you got to remember these positive protons, neutral neutrons, and negative electrons. So I usually think of evil electrons because that kind of things that are evil are negative. So negative electrons, right? Protons, neutral neutrons, right? I'm sure you've heard the joke. If not, it's real quick. It's a proton and a neutron walk into the bar. The proton asks for a drink, and the bartender gives him the drink, and then he charges him some money. And then the neutron gets a drink, but he doesn't get charged. And the bartender says to the neutron, "For you, no charge." Yeah, I know, not that great. Okay. Now, there are these things called quarks that protons and neutrons are made up of, and that are even smaller than protons and neutrons that we've just kind of recently discovered within the last decade or so. And for us, there's not much for us to know about them at this point, but it's just kind of important to know that there are these smaller subatomic particles that make up the protons and the neutrons. All right. This is a great tri-Venn diagram that kind of talks about the differences and the similarities between these 3 subatomic particles. So on your document, you have the outline of the Venn diagram there. It's not in color because it just didn't work as well. So it's transparent, which is fine. But what you can do is go through and you can start to fill in the things that belong just to protons, those that belong just to electrons, and those that belong just to neutrons, and the things in the middle. Okay, if you start having a hard time of placing things in where the circles cross over, go ahead and just insert text boxes and draw the box within those little crossovers of the circles for the Venn diagram. That might be easier than trying to hit enter or space bar or whatever to have everything line up. All right, so take a minute or two, do that now, and then come back and unpause the video, and we'll keep going. Okay, so let's take a look now at the atomic structure. So what is actually inside of an atom? So we talked about protons, electrons, neutrons. You just did the tri-Venn diagram there. So in the center are the protons and the neutrons, and we call this the atomic nucleus. So the nucleus is at the center of the atom. It's positively charged because it has just the protons in there that have the positive charge, and it does have the neutrons in there, but the neutrons don't have a charge, and so the overall charge of the center of the atom is positive. Now, what's unique about the atom and the nucleus of the atom is that because it has the protons and the neutrons, almost all the mass is there at the center of the atom in the nucleus. And so if you remember the atomic masses, or the weights of those protons, electrons, and neutrons, we noticed that the protons and the neutrons were about the same mass, whereas electrons were a lot less. And so this should make sense that if protons and neutrons are in the nucleus, then that's where almost all the mass is. Now, they are tightly packed together, so because of that, even though it's most of the mass for the atom, it's very little space. Okay, so the nucleus doesn't take up as much space as the outside cloud around it. And so when we talk about the nucleus of an atom, it contains almost all of the mass, but very little volume or space. Outside of the atom, outside of the nucleus, outside of the nucleus is this region called the electron cloud. And this is where the electrons are kind of just moving around the nucleus. And they move around in these different areas that are called energy levels. And that's going to be important when we start talking about bonding later this week. Now, the electron cloud is kind of the newest part of the model of an atom. So in previous models, as scientists learn more and more and more about the atom, they used to make different models to represent it. And some of them, even way back, there was this one that was called the plum pudding model. And this idea of that, like the electrons were kind of just like randomly placed throughout an atom, and they kind of looked like raisins that were in plum pudding. I know it's kind of silly. Well, the recent change, and recent is still a while ago, more than 25 years ago, but the most recent model is called the electron cloud model. It's because this electron cloud was newly discovered. And we knew that electrons were around the nucleus, but we thought that they were in these very fixed orbital patterns, almost kind of like a solar system, kind of, orbiting around a star or a sun. And so for this new model, the electrons are still outside of the nucleus, and they're still moving around the nucleus, but they're not quite as a set orbit. They do stay in these certain energy levels, and you can kind of even tell from this diagram here that they're representing different energy levels by some of the different yellows and oranges here. So the electrons will stay in certain energy levels, but it's not quite as a fixed orbit as what we used to think it was. And so this electron cloud is also called the electron cloud model of the atom because of that. And so it's within this electron cloud where all the electrons are, and they're orbiting around and moving around the nucleus of the atom, and it's negatively charged because the only thing in the electron cloud are the electrons, and electrons are negatively charged. It's the opposite of the nucleus. It contains very little mass, but because we know that electrons are much, much smaller in terms of mass than the protons and the neutrons, and it's just the electrons out there. So it's almost all of the volume of the atom. It takes up almost all the space, but it's very little mass of the overall atom. And it's important to know that because there's only a small number of electrons sometimes for an atom, all that area between each of the electrons is literally nothing. It's empty space. It's not like there's a gas in there or something else. It's literally nothing. It is just empty space. And so if we think about how the electron cloud takes up most of the volume or the space of an atom, then it's important to remember that most of an atom is actually empty space. You have this very dense nucleus in the center, and then you have these electrons flying around. But in between all those electrons is just empty space. And so that really is a lot of what the atom is. All right, so In the center, where you have the nucleus, you have the number of protons in that atom. And the number of protons in the atom is called the atomic number. Now, that's important for us because the atomic number is telling us the identity of the atom. And so when you look at elements and you see that the atomic number of carbon is 6 and the atomic number of oxygen is 8, that's literally telling us how many protons are in the center of the nucleus. And that's what gives it its identity. If it has 6 protons in the nucleus, it cannot be anything else except carbon. If it has 8, it can't be anything else besides oxygen. If it has 29, it has nothing. It can't be anything else except copper. That's how we can tell them apart. And you're going to learn that that's going to be one of the ways that the periodic table is organized by increasing atomic number. And because of that, that's going to give those elements very specific characteristics, especially the way that they interact with each other. And we'll learn more about that as we learn about the periodic table. So protons determine the identity of the atom. Now, every single element that is up on that periodic table is found electrically neutral, meaning that the number of protons and electrons are the same. So if that's the case, then that means that the number of protons and neutrons is also the same. And so that's important to remember as we learn more about atomic mass here. Now, not every single atom is electrically neutral. We're going to learn about isotopes and things like that, where you might have a positively charged atom or a negatively charged atom. And those are versions of some of the elements that we find on the periodic table, but we'll get to that later. All right, so if the number of protons determines the identity of the atom, and that's the atomic number, the atomic mass is also something important for us to know. So the atomic mass needs a little bit of math. It's the sum of the protons and the neutrons in the atom. Now, for us, we don't want to use those super small numbers like we saw with kilograms back on like one of the first slides that I showed you. And so there's also its own unit. There's a unit is called, for the atom, you have the atomic mass unit, which is called an AMU. So it's protons and neutrons that determine the mass of the atom. And so you just literally add those up. And you guys know then that you can kind of reverse that equation a little bit. And if you needed to find the number of neutrons and you knew the mass number and you knew the atomic number, then you would subtract those two and that would tell you the number of neutrons. So you can kind of rework the equation depending on what's given to you, which two things are given to you to be able to find the third thing. Okay, so it's important for you to remember atomic number, number of protons, how we find the atomic mass. It's the sum of protons and neutrons in the atom. There's going to be an activity we do later this week where you're kind of going through and you're doing all of that. All right, so for your element quiz 1, okay, element quiz 1 is going to be on Friday, even though I'm not there. You guys can do element quiz 1 without me. I have a doc here that has the 10 elements. Now, they're not the first 10 elements of the periodic table. We're going to learn a total of 20. So you'll have element quiz 1 this week, element quiz 2 next week. And these are the 20, I don't even want to say most common elements, but they're probably the most used or useful elements to know as you go through high school science, which would include next year with Mr. Singer. So it's good to already have these kind of in your brain on something that could be a quick recall so that you don't have to constantly be looking them up. Okay, I don't even think they make you memorize the whole periodic table anymore because it's so accessible through apps and through the computer and stuff. But when you're doing things in high school, it's going to take way, way longer, like double or triple the amount of time if you're constantly going back and having to look things up. Whereas if you kind of know 10, 15, 20 of these elements and you know what their atomic numbers are and their symbols are, it's going to help you get through things a lot faster. So click the link, make a copy because it's just my master doc, and so you'll have to make a copy so that you can edit it. And then you can use any periodic table that you can find. Just Google search one and find a periodic table, and you're supposed to be filling in the elements. The elements are there. So you need to put in the symbols and the atomic numbers. Make sure you're paying attention to the capitalization of the symbols because it's really important to recognize that if it's a single letter, it's always capital. And if it's two letters, the first is capital and the second is lowercase. That's really important. Okay, so capitalization is going to count on your quiz. Spelling is going to count on your quiz as well. Now for this, I'm going to make the atomic number extra credit. And here's how we're going to do it. There are 10 elements that you have to know. And so there are certain benchmarks that you have to get to with the atomic numbers, correct atomic numbers, to earn extra credit. So if you can get five of the atomic numbers correct, then I will give you a full point extra credit. And then if you can get all 10 of them correct, then I'll give you 2 points extra credit. Okay, but you got to reach those benchmarks. So if you get 4 of them correct, you don't get any extra credit. I'm not giving half points or quarter points. You got to get to 5. And then past 5, you have to get to 10 to get the second bonus point. So if you get 9, I know that stinks that you were just 1 away, but you're only going to get 1 bonus point because you didn't reach the 10. So 10-point quiz plus 2 points extra credit. Technically, you have a chance to earn 120% if you're able to do the symbols and the atomic numbers correctly. Now, I'm going to make it a little bit harder than just the symbols. When you take the test, 5 of them, I'm going to give you the names and you have to give me the symbols. And the other 5, I'm going to give you the symbols and you're going to have to tell me the names and spell them correctly. So it's going to be really important for you to know them both ways because you don't know which 5 I'm going to ask you for the symbols and which 5 I'm going to ask you for the names. So make sure that you know them both ways, both by recognizing the symbol when you see the name and when you see the name, you know the symbol. Okay, and that's going to be Friday. So use the rest of the time now to write those out. If you still have some time at the end of class, then you can start to study these. Okay, I will see you in class next time. Have a good rest of your day.